I'm David Crandall. I teach in the informatics and computer science programs here, and I represent half, roughly, of the work in computer vision here at IU. The other half is Michael Rue, who's going to talk a bit about his work in a few minutes. So computer vision is, the goal in computer vision is really easy to state and really, really difficult to do. So the idea is, given an image like this one, as soon as you or I look at this, we immediately start sort of understanding the scene. Without even thinking about it, we recognize the building, the fountain, we see the people. You probably recognize where this photo was taken, maybe when it was taken. You make inferences about what the weather was like this day, what these people are doing, and so on. This is our goal in computer vision. It's to be able to understand images and imagery at a semantic level, the way that people are able to do this. This is a really hard problem, and so we attack it from various angles and using various strategies. And I thought today I'd just show you kind of a whirlwind tour of some of the projects that we're working on. And if you have any specific questions or are interested in any of them in particular, you can stop by or check out one of our papers for more information. So on one hand, we work on very basic building blocks that are useful potentially across a range of applications, like detecting people and images and figuring out what they're doing, or detecting particular species of, particular classes of objects, including even really hard recognition problems like particular species of birds and differentiating between them. A lot of our work involves helping people organize huge collections of images, like the millions and billions of images that are on social media these days. So among other things, we have a project, a long-running project, on trying to figure out where on Earth a photo was taken automatically using just the visual content of the image itself. We've also done a lot of work in 3D reconstruction, taking images from a particular landmark and producing a 3D model of that landmark, which is useful both in its own right, but also so that we can organize new images as they come into a system. We're also really excited about interdisciplinary applications and collaborations. So to give a couple of examples, with Professor Jeffrey Fox and others, we're working on understanding automatically imagery taken from polar science, from the polar ice sheets, to monitor how climate change is affecting the ice automatically. With Professor Chen Yu over in psychology, we have a long collaboration on using vision techniques to automatically code and model behavioral data collected from kids and parents wearing cameras actually on their head, so that we can monitor what they're looking at and what they're reaching for, and so on. A lot of our recent work has been trying to understand the challenges and opportunities of a world where cameras are everywhere. In fact, I think I count at least 6 cameras right in this room right now that are clearly visible, including this little one that I'm wearing right here, which takes a photo every 30 seconds throughout my day. And it's kind of cool. I was really skeptical at first, but it's kind of cool. At the end of my day, I get this visual representation of everything that I've done. But there's 2 problems with this. The first is that I get thousands of photos, and most of them are terrible, and it's really hard to find the good ones. And the second is that I get some images that are really, really terrible, like the ones that I get when I walk into the bathroom and forget to take this off, right? So we're interested in understanding what sort of the privacy implications of these wearable cameras and ubiquitous cameras are, and can we develop technological solutions to help people protect their privacy in this world, in this new age of photography. And these seem like really diverse projects. Underneath the hood, we have some common themes. Some of the themes are probabilistic graphical models, machine learning, especially deep learning, which has become very popular in vision in the last few years. We use large-scale data sets, large-scale computation, and like I mentioned, we're really excited about interdisciplinary applications and collaborations. And so with that, I'll just thank all of the people who've collaborated with us, and my students and sponsors, and mention our websites in case you'd like to find out more. And of course, you're more than welcome to stop by if you're interested in chatting about this or anything else. Thank you.